Hello viewers. As we all know that in the world of technology there are a number of innovations, inventions, discovery and so on. But something called 3D printed technology is known to all, but complete information is yet to be there to the public. So today we are here with Dr. Birinchi Panda sir, who is the Assistant Professor of Mechanical Engineering Department. So from sir we will learn what this technology is all about and how it will benefit the common masses and what are the business opportunities startups can take from this technology. So welcome to Business Conversation, sir.
Good morning. Thank you for inviting me for this discussion. So I'm an assistant professor in the mechanical engineering department. So here we do research on the 3D printing technology.
Hello, sir. Sir, please tell us about the 3D printed technology.
Okay, so this 3D printing technology that we are dealing here is a digital technology. So what we are trying to do here in this technology, we are trying to deposit a material uh, following a digital file. So basically what happens, you want to create a complex geometry. So using traditional technology, this geometry fabrication is quite critical. So through 3D printing, we have a digital file. So like in computers, we create the shape that we want, and then we send the information to a machine that called 3D printers. It can be a robot, it can be a gantry machine, where this machine is going to deposit the material in the layer by layer form. So there are many technology of 3D printing systems. It can use laser, it can use completely extrusion. But currently in our research group, we are trying to focus more on the extrusion based 3D printing materials. So what happens here, like we have a material design. So the material passes through an extruder and we deposit it layer by layer to make the complete structures. So that's how 3D printing system works. And for concrete like materials, once you print the entire design, we allow it for curing. So once it's cured, it's going to get enough strength for application, and then we complete the process.
Okay. So how the 3D printed house or structures are different from the concrete structures that we see?
Okay, madam. So in this regard, if you see that traditionally the concrete houses, or even if you say brick mortar based system, we have a technology where we have to make a concrete material, we have to go with precast or formwork based manufacturing. So typically what happens, you have to create a formwork and you have to mix the concrete and put in the formwork to get the structure. In this process, it takes quite a lot of time, because you have to make the formwork, you have to bring the labor people to work on the technology. But in 3D printing, what is the difference we see, that you don't have to go by the traditional approach. There are applications where through 3D printing you can make more lightweight structures, because in the 3D printing we have the uh, freedom to put the material in a predefined shape. Let's say you want to make a wall. So traditionally I must use a precast or brick mortar wall, but if I opt for a 3D printing technology, I may not have to make it purely solid, rather I can make it more lightweight. How it is possible? So what I can do through 3D printing, the wall can be modular, as well as this wall can have some internal pathways. This internal pathway can fulfill two purposes. One is your lightweight system. Second, it's going to bring some functionality into the wall. So earlier the wall that you have seen, it is just a wall. It does not have any function. But through 3D printing, you can eliminate a function here. So the wall is not going to only carry the structural load of the building. Moreover, it's also going to act as functional elements. You can have better control of heat, you can have more lightweight features, you can also put some kind of plumbing electricity connections inside the wall, so that this wall can behave like a multifunctional unit. It can take the load, it can also protect you from the outside environment, it can also give you modularization, so that anytime you want to bring different modules, you can connect it. But through traditional way, you have to deal with a complete solid wall where you don't have any options to bring function into it.
Okay.
So the additional benefit what we get by 3D printing, we can make it more lightweight, we can design our own wall accordingly. But if you go with traditional technology, you have to use the wall as it is. Like these walls are being developed, you have to use as it is. We can't have our customization. But through 3D printing, since we are allowing the material to deposit in a predefined path, here we can control the wall property. That is more important. So you can customize it according to the country need, location need. Here I need a very humid environment, accordingly I can design my wall. So in the northeast, basically, when you see that we have high altitude area, we have different terrains. Here also in IIT Guwahati we experience different weather. So we aim to print the wall specific to different geographical locations. But in conventional way, these things are not quite easily possible. So that's how we see the 3D printing technology can be give you more customized solution.
So what is the lattice pattern 3D concrete wall means?
Okay, madam. So, what is the difficulty we have here in conventional way? As I told you, these walls are solid, so you don't have any options to play with the internal architecture. But in 3D printing, let's say you want to print a wall. So, in the wall, what we typically do, we try to design new lattice patterns. These lattice patterns are like you can see like in honeycomb structures. When a honeybee try to store the honey, so we have a honeycomb designs. So these are more like lightweight designs. So we try to embed this design inside the wall. So we have the wall having one cover surface. We have internal architectures also. So with the cover wall, we can play with the internal design. Like you say, sandwich structures. What they have? They have one outer profile, one inside patterns. In the similar tone, what we are trying to develop here, we have a wall. The inside of the wall, the middle portion of the wall has been designed like a more lattice patterns. It's a like more design patterns. The benefit is that by designing proper architectures, we can control the heat flow inside the building. We can also control the structural property of the building. So that is how we are designing with new lattice structures that can take the structural load more efficiently. At the same time, this design is going to control the incoming heat through the wall. So these designs are going to control your property as well as the function.
So is it true that 3D printed concrete structures are means they can bear the earthquake or other natural disasters?
Madam, right now there is no specific literature that takes care about this point. But in our group right now, we are also exploring the seismic resistance of this 3D printed wall. So we have received our first set of results from experiment as well as from simulation. We have seen that if we can properly design this 3D printed wall, it can also take the seismic load. But again, see, this is a new technology, so not much research has been explored on this earthquake property. But again, the point what I want to highlight here, that through proper R&D, we can design the wall in such a system that it can able to resist the earthquake load. So we have some sort of new designs following some codal provisions, and we have seen that with proper reinforcement and proper materials, these walls can take care seismic loads carefully.
Okay. So what kind of researches are taking place in your institute for this, and how entrepreneurs can be benefited from this kind of technology?
Yeah, so basically to answer this question, I would say in our laboratory, we take care of the material part of 3D printing technology. So we try to use local waste to make more sustainable materials. So if you know that in Guwahati also, we have lot of waste materials. So government is putting their best effort to utilize this waste. So one good thing what we can do, we can use this waste, for example, plastic bottles or any kind of like industrial waste. We can incorporate this waste to formulate a material for our application. So there are a lot of industry startup who are going to take care about the waste management. So for them, it's a good opportunity. They can take care of this waste through 3D printed material development. Secondly, once the material is designed, we have applications. So in the application domain, there are a lot of applications. So I have been working here almost 6 years. So I have been in touch with many industry as well as government office. So I came to know that in Northeast we have a very huge demand of that housing sectors. So basically, I would like to urge to all the startup entrepreneurship people who are going to work in this topic. There is a big opportunity coming up in the next few years where we can use the technology to make some kind of modular housing. And regarding the costing part, it is yet to be confirmed because it depends on the number of units we are printing it. So one is the material development task. Once material is with your hand, then you can bring this material for innovative project like modular housing design, where our Prime Minister Awas Yojana can be also pitched in. So we can talk about these modular blocks can be used for designing a self-sustainable, resilient housing in the Northeast, and we are also working here for this project. And I believe that I think the students graduating from IIT Guwahati, they will take the lead in doing all this kind of project for the benefiting Northeast people.
Okay. So what kind of collaborations is there with your institute for developing this kind of if this kind of things and make putting it forward?
So till now, madam, we have closely worked with Indian Army. So we have delivered one sentry post with a group of army people. So we have realized that, especially for the army who are constantly visiting northeast high altitude area, there we need technology that can be easily deployable, because it is very clear that for such a very difficult terrain, it's difficult to go and construct anything for them. So therefore, we have a agreement with Indian Army, Eastern Command. So where we are trying to develop some kind of 3D printed sentry post for them. So what exactly we have done for them in this project? We have used our technology. We have used our own material design to print a sentry post for them. And in this sentry post, what is the biggest challenge we have learned from our first project? That the temperature control is the key issue. When we are going to put this kind of sentry post in the high altitude area, because of the weather issue, we need to ensure that who are staying inside the sentry post, they get a comfortable feelings. And earlier we have deployed structures without considering this aspect. So recently, the publications we had in the journal called Progress in Additive Manufacturing, we further explored that in such kind of application, if we can control the lattice wall patterns, we can also control the thermal behavior of the wall. So therefore, we are now trying to again reach out to them, saying that earlier the sentry post we have developed, it was not thermally controlled. Rather, now we have a new avenue of research where the same sentry post can be redesigned to take the blast loading, as well as it is also going to provide some kind of comfort depending upon the weather they are working. So this is how we conducted our first project, where only we delivered a structure to them, and then we didn't do any kind of research on thermal as well as structural testing. Right now, we have realized that these two properties are quite important for the army who are working in the high altitude area, and therefore we have taken another research where the wall internal lattice pattern can be redesigned to take the structural load, earthquake load, as well as the thermal behavior. So these 3 points we have tried to address in our this current publication, and we are hopeful that now if we want to again redesign the sentry post for them, it's going to much more effective, improved design for the application.
Okay. So the next question is, what kind of challenges this kind of innovation has, and do you think this kind of technology will be accepted by common masses?
So basically, this technology has already been in the industry for last 10 years. So we have seen this technology is quite useful for many applications, yet there are some significant challenges. The first challenges we have seen quite often from industrial people is a lack of standards. Currently, this housing application, sentry post application are not in line with any existing standard, because this construction 3D printing what we are talking about today, it has no genuine standard to follow. So therefore, we are trying to follow some existing standards. So now we need to come up with a new standard so that industry or the users, they can accept our product. Second thing, this technology is not a all-in-one solution for everything. So what we have seen here, that this technology can only print walls and some component of the building. It is still in a research phase that we need to explore more for printing like roofs, because till now there is no research where the roof of the building has been 3D printed. Only wall panels and some of the components of the buildings are 3D printed. So we need to also look into that aspect also, that how in future we are going to automate this completely building fabrication process, because right now it's in bit and piece. We are only printing the walls, the roofs are not 3D printed. So that is the second challenge we have seen. Third is the material challenges. When we are going to talk about using industrial waste, the property of this waste keep on varying from place to place. So if we want to go for commercialization, the problem is that this waste material, they have a variable property. Let's say if I take a raw material from Guwahati and another raw material from Chennai, they're going to have different properties. So every time locally I have to tailor the solution. So there is no one sort of formula for all applications. Every time we have to tailor the solution based on the material. Standards need to come up with this kind of technology booming in construction domain. And also the, as you ma'am said, like seismic property, also the costing, affordability, these things need to really work out. So then the technology can be viable for many applications. But I feel, being in academia, from academia, if we want to prove this to industry, we need to take projects. We have to work with industry. So maybe at initial level, like how government is encouraging us to work, that in some applications we are trying to put our design structure up to certain percentage, and then we are trying to validate that whether our technology is able to meet the key requirements. Okay. And if it is not, then again we are working for that. We are trying to improve our technological features to meet those targets, and slowly this is how the technology is going to evolve over the years. Okay. Right now these challenges are critical, and I believe researchers from across India and outside India are trying to address these issues, because construction 3D printing is getting more attention from industry and academia in recent years. Okay. Many projects are being carried out by industry and academia, but if we can solve these challenges, definitely it's going to enter into the market with a huge impact. Okay.
So what is the future of this technology, and where do you see this technology in this region in future?
Basically, madam, in this technology, if I talk about the real impact in the northeast, I believe, because in the northeast, since we have very difficult terrains, okay, so construction in different terrains is very difficult. Okay, unlike like cities, we have very irregular plans. So there I think we can definitely use the technology to create some structures which are difficult to do through conventional way. I have recently visited some northeast regions where I have seen that it's very difficult to carry all the raw materials to the high altitude area, do entire fabrications. But what I see, the benefit that 3D printing is offering, that let's imagine that the entire machine, including the material delivery system, you put in a compact vehicle, and this vehicle goes to the high altitude area. You can immediately create the entire shelter on site. So that is the second benefit of 3D printing, that you can do on site 3D printing and with a complete full-fledged machine, and this machine can deliver quality products. Okay. So this is how I feel this technology can save the how we construct the building in the northeast. In addition to that, we have also realized that suppose this technology is going to be implemented in some very difficult reachable place, so we are also in a plan to take the help of a drone mission, where this drone can carry this modular blocks to the top areas. Okay, so maybe in the low altitude area we can put a machine that can print these blocks, because as I told already, this carrying all the raw material to top altitude is very difficult. So at some point near to the main location, we can have the machine that can print continuously these blocks. Then drone can carry these blocks to high altitude area for easy assembly. So that's how we can see technology can really benefit for the northeast area, where doing things through conventional technique takes more time and also very challenging.
Okay. Thank you so much, sir. All our queries are solved. So, viewers, this is a thing, and we have learned a lot from sir. So, keep watching Business Northeast for all this kind of new information, which will be helpful for you. This is Priyanka again. Thank you.